Better get this thing down in a hurry. The wing spar is burning badly. That's what a radio operator called into Boeing Field, Seattle, on February 18, 1943. 8 minutes into a routine test flight, one engine had caught fire. The pilot at the controls was Eddie Allen, the most respected test pilot in America, the man who had first flown the Stratoliner and, 5 weeks earlier, the Lockheed Constellation. On final approach, the burning wing gave out. The aircraft came down on a meatpacking plant. All 11 people aboard died. So did 20 more on the ground. The engine behind that fire would go on to power the plane that carried the atomic bombs that helped end World War II. This is the Curtiss-Wright R-3350. The Boeing B-29 needed an engine nothing else could match. Enough power to lift a bomber capable of striking targets thousands of miles from any friendly runway. The R-3350 was an 18-cylinder, 2-row radial, built to deliver over 2,000 horsepower, more than almost anything flying in 1942. But the B-29 program was already years behind schedule, with the war demanding results faster than the engineering could responsibly deliver. The R-3350 had been in development for years, but it was still struggling with serious reliability and cooling problems when it entered B-29 flight testing. The flaw that made those early engines so dangerous was rooted partly in the engine's basic layout. 18 cylinders packed into 2 tight rows meant the rear row received far less cooling airflow, shielded from the wind by the row in front of it. Those rear cylinders could run dangerously hot enough to ignite leaking oil and fuel around them. And once a fire started, it had something extra to burn. Sections of the crankcase and other engine components were cast in magnesium alloy, light and strong. But once ignited, extremely difficult to extinguish. A fire that started as a fuel leak, oil leak, or induction system problem could become intense enough to damage the surrounding structure. The Eddie Allen crash exposed all of this before the B-29 had even entered combat. It reached all the way up the chain of command. Franklin Roosevelt himself was already frustrated by the program's delays, and the disaster intensified pressure on the entire project. Engineers spent the next year chasing the fire risk from every angle. Better baffling redirected cooling air into the starved rear cylinders, revised cowl flap procedures gave crews more control over engine temperature in flight. And Wright eventually replaced the original carburetors with direct fuel injection, improving fuel distribution and eliminating a combustible fuel-air mixture from parts of the induction system, reducing the risk of fires caused by severe backfires. None of it fully solved the danger. B-29 crews flying combat missions over Japan in 1944 and 1945 still lost aircraft to engine fires, a risk that became, grimly, just another part of flying the mission. But the rate improved enough for the aircraft to fly the bombing campaign against Japan, including the missions that carried the atomic bombs. After the war, the R-3350 didn't retire. It evolved. Wright's engineers added something new: 3 exhaust-driven power recovery turbines, connected to the crankshaft through fluid couplings, recovering power that would otherwise have disappeared out the exhaust. They called it the turbo compound. It pushed the same basic 18-cylinder layout that had once been plagued by fires toward 3,400 horsepower, making it one of the most powerful piston aircraft engines ever put into widespread service. Airlines picked it up for some of their biggest long-haul aircraft, including the Douglas DC-7 and the Lockheed Constellation family, flying transatlantic routes through the 1950s. It wasn't a perfectly clean redemption. The turbo compound earned its own reputation for complexity, demanding maintenance, and occasional engine trouble. But it flew on, reliably enough, for nearly 2 more decades, longer than almost any other large piston engine of its era, right up until jet airliners finally made it obsolete. The R-3350 never stopped being a difficult engine. It just became difficult enough, for long enough, to help power a bomber that changed the course of a war, and then carry passengers across oceans for years afterward.